So let's take a look at a problem or two out of 6.1. So they give us a triangle, they list some sides on it, list a particular angle calling it theta. So then they ask for the 6 trigonometric function values. Sine of theta, tangent of theta, and then cosecant of theta, secant of theta, and cotangent of theta. So a couple of things, the functions are always of some angle. There could be a number there for the angle, or it could be given a letter, but these are functions. The first three letters let us know which function it is, and then the angle lets us know what our input is. So from theta, if this is our input, we want sine. And the definition of sine is opposite divided by the hypotenuse. And it's technically opposite of the input. So if the input is theta, the opposite side is 9 square roots of 3. The hypotenuse is 18. So the opposite side from the input divided by the hypotenuse. Cosine is adjacent over hypotenuse. Adjacent to what? Adjacent to our input. So the side that's adjacent to theta is 9, and the hypotenuse is 18. Both of these reduce. The first one, 9 goes into 9 and goes into 18, giving us square root of 3 over 2. The second one reduces to 1/2. Tangent theta is opposite of theta over adjacent to theta. So opposite of theta is 9 over root 3. The adjacent side to theta is 9. And that reduces to the square root of 3. Now the other three ratios are just the reciprocals of these. Cosecant is the reciprocal of sine. I often remember it as the C's don't go together and the S's don't go together. So the C goes with the S. The S here goes with the C here. So cosecant is the reciprocal of sine. So hypotenuse over opposite. Hypotenuse is 18. Opposite is 9 roots of 13, which we had already reduced that. And if we flipped that, that would be 2 over root 3. That's fine. We don't necessarily have to rationalize the denominator. But if we do, we would multiply top and bottom by root 3. That would give us 2 roots of 3 on top. 3 times 3 is 9, and the square root of 9 is 3. So that would give us cosecant of theta. Secant is the reciprocal of cosine, so that's hypotenuse over adjacent. If we flip that, cosine came out to be 1/2. Secant would come out to be 2 over 1, or 2. Cotangent is the reciprocal of tangent, so that would be adjacent over opposite, which is 9 over 9 roots of 3. If we reduce that, we would get 1 over root 3. And if we rationalize the denominator, multiply top and bottom by root 3, so that would give us root 3 over the square root of 9, which is 3. So that would be cotangent from theta. So the biggest thing here, or one of the biggest things here, is recognizing the definitions of our ratios. Let's take a look at the next one. So let's just sketch a triangle. So sine, if we call an angle theta, sine is the opposite side over the hypotenuse. The opposite side from theta over the hypotenuse. So we could draw a triangle that has an opposite side from theta to be 60 and a hypotenuse to be 61. Well, if this is a right triangle, then we can use the Pythagorean theorem to get the other side. Remember that C is the hypotenuse. So if we just called this, let's say x squared plus the other side squared would be equal to the hypotenuse squared. So 60 squared is 3,600. If we take out a calculator and do 61 squared, we would get 3,721. Subtract 3,600 from both sides. So x squared is 121. If we take the square root of both sides, we get that x is 11. So this other side is 11. So if we know one of the ratios, then we could draw a triangle that has those two sides. Pythagorean theorem gives us the other side over hypotenuse. Opposite over adjacent. And then just the reciprocals. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. If we take a look at this way, we could call cosecant theta equals 1.4. We could write that as a fraction if we want to. We could leave this as a fraction with a decimal on top, or typically we don't like decimals in a fraction. So to move that decimal over, we could multiply the top by 10 to move it over one spot and multiply the bottom by 10. So that would give us 14 over 10, which reduces to 7/5. Oops, it doesn't exactly connect. Cosecant, remember that's the reciprocal of sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So if we simplify 1.4 and convert that into a fraction of 7/5, then from theta, the hypotenuse is 7. The hypotenuse is across from the right angle. The side opposite of theta would be 5. We could have left it as 14 and 10. We would have come out with the same ratios once we reduced. Or we could do the 7 and the 5. Once we have those sides, x squared plus 5 squared equals the hypotenuse squared. So x squared plus 25 is 49. Or x squared is 24 when we move the 25 over. Square root of both sides. Notice 24 is 4 times 6. So when we take the square root of that, the square root of 4 is 2. 6 is not a perfect square. So we could call that 2 square roots of 6. And then we would just write each of our ratios using those sides. So sine is opposite over hypotenuse. Is adjacent over hypotenuse. Tangent is opposite over adjacent. We can multiply top and bottom by root 6 to rationalize the denominator, so that would give us 5 square roots of 6 on top. The square root of 6 times 6, that would be the square root of 36. So we have 2 times 6, or 12 on bottom. My math lab may not make you rationalize denominators, but you can here. And then we would just list our other two ratios. We don't have secant or cotangent yet, so we would just list those. When we're given angles like this, there are two triangles that we're going to use commonly. One of those is a 30, 60, 90 triangle. And the sides of a 30, 60, 90 triangle are 1, 2, and the square root of 3. Anytime we have a 30, 60, 90 triangle, or a problem involving a trig ratio of 30 or 60 degrees, we can use this triangle. So if you ever forget which sides go where, first of all, the sides are 1, 2, and the square root of 3. The smallest of those numbers is 1. 1 goes across from the smallest angle. Of the remaining two, 2 is actually the biggest. 3, square root of 3, we could get that as a decimal. That's going to be less than 2. So 2 is the largest. 2 has to go across from the largest angle. The largest angle is the right angle. So 2 would have to go there, and that leaves root 3 on the other side. So secant is the reciprocal of cosine. So secant is hypotenuse over adjacent. Hypotenuse is 2. The side adjacent, well, adjacent to what? Adjacent to 60 degrees. Well, the side that's adjacent to 60 degrees is 1. Now you might say, why not 2? 2 is the hypotenuse. Adjacent means the side that is beside our angle that's not the hypotenuse. So adjacent to 60 would be 1. Hypotenuse is 2, so secant of 60 degrees would be 2. The other triangle that we commonly use is one that is a 45, 45, 90 triangle. And it typically is listed with sides of 1, 1, and the square root of 2. It is opposite over adjacent. So pick a 45-degree angle. The side opposite of 45 degrees is 1. And the side adjacent to that 45 degrees is also 1. Is 1. Just using that triangle. So 30, 60, or 45 degrees, we're going to use one of those two triangles. So those are triangles that you need to memorize. Now, let's look at a problem like this. And instead of using this one, I'm going to use 11 degrees, 36 minutes, 12 seconds. And let's convert this to decimal degrees. This is referred to as degrees, minutes, and seconds. Degrees, minutes, and seconds. Sometimes angles are listed this way. Sometimes they're listed as decimal degrees. The full degrees in it, and then the decimal part of the degree. The remaining portion of the degree written in decimal format. So we need to know some facts. In 1 degree, there are 60 minutes, and in 1 minute, there are 60 seconds. So if we're going from degrees, minutes, and seconds to decimal degrees, we want to start with our seconds, and we want to convert those to the next unit. So 12 seconds, if we convert those to minutes, well, this equation relates seconds and minutes. If we have seconds on top here, we're going to put seconds on bottom, and those are related to minutes. 1 minute and 60 seconds are equivalent to each other. Remember, if we have a fraction that has the same amount on top and on bottom, anything divided by itself is 1. If we have the same amount on top and bottom, that's 1. And if we're just multiplying times 1, it doesn't change how much we have. It might look differently, but it doesn't change the amount. So the reason we put seconds on bottom was so that the units would cancel. If we have a common factor between top and bottom, they cancel or they reduce. And we're left with units of minutes. So we have 12 on top, 60 on bottom. 12 divided by 60 is 0.2. So 0.2 minutes. So 12 seconds is equivalent to 0.2 minutes. So that means we currently have 11 degrees, 36 minutes, and 0.2 minutes. Well, 36 and 0.2 would be 36.2 minutes. So we want to take the 36.2 minutes and convert that into degrees. So if we have minutes on top, we would put that same unit on bottom so that our units cancel, and we're converting to degrees. Well, 1 degree is 60 minutes. So we're left with units of degrees. We have 36.2 on top, 60 on bottom, so 36.2 divided by 60 gives us 0.603 repeating. 0.603333333. So that means if we convert that portion into degrees, that's 0.603 degrees. So if we have 11 degrees and then 0.603 degrees, we have a total of 11.603 degrees. And this would be exact, or we could round that to however many decimal places are required. So since we only multiplied by an equivalent fraction of 1 each time, multiplying by 1 doesn't change our amount. It just puts it in a different format. So those two ways of writing that angle are the same amount, just degrees, minutes, and seconds or decimal degrees. This one we're going in the opposite direction. We have decimal degrees, and we want to convert it to degrees, minutes, and seconds. 8 full degrees, 88 complete degrees, and then the 0.534 tells us the portion of a degree that we have. So we want to take the 0.534 degrees and see, well, how many minutes does that include? If we're rotating 0.534 degrees, how many minutes is that? So if we have a degree on top, put degrees on bottom, and we're changing to minutes. 1 degree is equivalent to 60 minutes, so the unit on top and bottom that match cancels. This leaves us with minutes. So 0.534 times 60, 32.04. And that's in minutes. So at this point, we're at 88 degrees, 32.04 minutes. So that means we have 88 full degrees, 32 full minutes, and then we need to take the portion of a minute and change that into seconds. We don't quite have 33 full minutes. We have 32 full minutes and then a little bit more. So if we change that, minutes on top, we would want to put the same unit on bottom, and we're changing to seconds. 1 minute equals 60 seconds. So our minutes cancel. 0.04 times 60 gives us 2.4, and that leaves us with seconds. So if we convert that decimal degree to degrees, minutes, seconds, that would be 88 full degrees, 32 full minutes, and then 2.4 seconds. Now, one reason we do these conversions from time to time is sometimes we need to use our calculator to calculate a trig function for something that's not in decimal degrees. And if our calculator does not allow us to put in minutes and seconds, then we would need to convert 42 degrees, 42 minutes into just decimals. So the part that's not already in degrees, the 42 minutes, let's convert it to degrees. So minutes on top, minutes go on bottom, degrees on top, and 1 degree is 60 minutes. So the minutes cancel. 42 over 60 makes 0.7 degrees. So 42 degrees, and then the minutes is equivalent to 0.7 degrees. So our angle is 42.7 degrees. That's not our final answer. That's just what we're going to take tangent of. Well, we need to make sure that our calculator is in degrees. Our angle is 42.7 degrees, and we're taking tangent of that. So normally we take that to about 4 decimal places. So if we round that to 4 decimal places, we would get 0.9228. So if your calculator allows you to put in an angle like that, then you can just put that angle in and click tangent. But if it doesn't, we would have to translate that angle to decimal degrees and then take tangent. Here, we're given the ratio, and we're wanting to find the angle. Our ratio is 0.8272. That's not one of our standard ratios that comes off of a triangle. So if that's the case, and we need to know our angle, then there's a little button on our calculator, usually that looks something like this. This is referred to as inverse sine or sometimes arc sine. For regular sine, the input is an angle. The output is the ratio that corresponds to that angle. For the inverse sine, it's backwards. The input is the ratio. The output is an angle that has that ratio. So our ratio that we know is 0.8272. If we hit the inverse sine button, it will tell us what angle has that value for sine. So to the nearest tenth of a degree, that would be 55.8 degrees. So I would try to type that into my calculator and see if I get that. The biggest things is our angle has to be in degree mode, not in radians. Oh, I just flipped my computer upside down. All right, the last thing I believe that we're going to look at in this section is that there is a relationship between complementary angles. Let's see. If this is a right triangle, remember that the interior angles of a triangle add up to 180. If it's a right triangle, that means this angle is 90 degrees. Well, that means we have 90 degrees left combined between the other two angles. So the other two angles must combine to make 90. Angles that combine to make 90 degrees are complements. So we know that 42 degrees and the other angle add up to 90. If we solve that, we would get that this other angle is 48 degrees. So all three angles add up to be 180. These two that are not the right angles add up to be 90. So what are they trying to get us to see here? Well, sine of 42, from 42 degrees, the opposite side is here, and the hypotenuse, of course, is here. Well, this side, I'm just going to call this side X, and this side Y. The side I label as X is opposite of 42 degrees. It's adjacent to 48 degrees. So just using the letters on that triangle, sine of 42 degrees would be X over H. Opposite of 2 degrees over the hypotenuse. But if we consider X to be the adjacent side to 48, that would be cosine from 48 degrees. 45. You might say, do what? Notice from 48 degrees, cosine is adjacent, so the adjacent side over the hypotenuse. So cosine of 42, or sine of 42 and cosine of 48 have the same sides involved. From 42 degrees, the opposite side is x. From 48 degrees, the adjacent side is x, and they both have the same hypotenuse. So that means that sine 42 degrees and cosine 48 degrees are going to be the same. So if we're asked what is cosine of 48, cosine of 48 is the same as sine 42, which is 0.6691. All right, let's look at the next one, or the first one, sine of 48. So sine of 48, so from 48, sine is the opposite, so y over the hypotenuse. Well, that's from 48 degrees. What about in terms of 42 degrees? Well, y is adjacent to 42 degrees. Which trig ratio involves adjacent? That's cosine. So cosine from 42 degrees is adjacent y over the hypotenuse. So while y over h is sine from 48 degrees, y over h is cosine from 42 degrees. From 48, this is opposite, and that's hypotenuse. From 42 degrees, the same sides are adjacent in hypotenuse. So sine of 48, same as cosine 42, which is 0.7431. Now, tangent of 48 from 48 degrees, tangent is opposite over adjacent. What about from 42 degrees? What is y over x from 42 degrees? 2 degrees, y is adjacent, x is opposite. So y is adjacent and x is opposite of 42 degrees. So adjacent to 42, opposite to 42. Well, adjacent over opposite is cotangent, and our input is 42 degrees. So tangent of 48, cotangent of 42 is the same thing, so this would be 1.1106. So if we know sine of an angle, we know cosine of its complement. If we know cosine of an angle, we know sine of its complement. Tangent and cotangent go together, secant and cosecant go together.